Welcome to my channel. Let's see how to reduce matrices to echelon form, or how to write a matrix in echelon form. So the first thing that we do is we need to know, when do we say that a matrix is in echelon form? So a given matrix will be said to be in echelon form if it fulfills the following two properties. The first property is that the first non-zero entry in each row, each non-zero row, must be in a column that is to the right of the other leading entries. So if we have the leading entry in row 2, the column that leading entry is in must be to the right of the column of the leading entry in row 1. And the other property is that the rows consisting entirely of zeros must be at the bottom of the matrix. Now, so let's just note that we say that a matrix is in a row echelon form, or somebody may opt just to say that it is in echelon form. So the two mean the same. When we talk of row echelon form and talk of echelon form, row echelon form and echelon form mean the same thing. So we just need to look at a few examples just to ensure that the two properties that we've looked at, property 1 and property 2, are clear to us. Now, these three matrices that we're seeing here are in echelon form. So I just want to use them to illustrate the two properties. This is a non-zero row, So the first element in this non-zero row, the first non-zero element, the first non-zero element in this non-zero row is 2. So we call this the leading element in this row, leading element 2. This is also non-zero row, and the first non-zero element is 2. So it's the leading entry in this row. This is another non-zero row, and the first non-zero element in this row is a 1. So we call it the leading 1. So what I mean therefore is that this element, leading element in this row, is in column 2, and this one is in column 1. So this one is to the right of this. And again, you can see that this leading 1 is also to the right of this other leading entries above it. Let's come to this other matrix. This is a non-zero row. The first non-zero element, the leading element, is 1. The first non-zero element in this second row is this. So it's the leading element for this row. And for this other row, it's this. So you can see that this leading element is to the right of this, and this one is to the right of this. And that is what property 1 means. That every leading element must be in a column that is to the right of the other leading elements above it. And what property 1 means is this: that a row that is made of entirely zeros must be at the bottom of the matrix. The leading element in first row is this. The leading element in the second row is this, and you can see it's to the right of this. The leading element in this other row is 1, and it's to the right of these other rows. These are the leading elements. And finally, the leading element is 5, and you can see it's to the right. It is to the right of the other leading elements. So that means, as we proceed, for us to write a matrix in echelon form, we'll be considering that. That every leading element must be to the right of the leading elements above it. So the question is now, how do we reduce a matrix to echelon form? So to reduce a matrix to echelon form, we perform the following elementary row operations. We can reduce a matrix to echelon form by either interchanging rows or adding a multiple of a row to another row, or by multiplying a row by non-zero constant, or by combining these properties, these operations, combining these operations. So you may combine these operations so as to reduce a matrix to echelon form. So the process of performing the elementary row operations on a matrix is what we call row reduction. So by row reduction, just mean apply the elementary row operations on a matrix to bring it to echelon form. Bring it to echelon form by performing these elementary row operations. Now, so very interesting is that let's now look at how to reduce a matrix to echelon form by performing the elementary row operations. So we look at the first example, and the example is reduce the following matrix to echelon form. So there are two ways you can proceed from this. The first way, you may want to keep this two the way it is, and then use it to create zeros below it. Create zeros below it. Or the other option is to create a 1 in this position the way I did, and then use this 1 to create zeros below it. And of course, that is what we'll be doing. To reduce a matrix to echelon form, we are interested with this element. Use this element to create zeros below it. This element is in row 1. Now come to row 2 and create the leading one. No, the leading element in a row. Create the leading element in row 2. And once you create the leading element in row 2, create the zeros below it, and so on. That's what we'll be doing. Now, what I did is that I did not want to work with these two because I thought that would be tedious in some way. So for me to simplify my work, what I normally do, I want to ensure that the leading elements in every row are 1s. That is to make my work easier. I want to ensure that the leading element in every row is a 1. Although you may want to work with the element which is already there. For instance, in this case, you may want to work with this 2. But for me, I'm seeing that would be hard. It would be to consume a lot of time. It won't be hard, but consume a lot of time. So I want to make it a 1. So to make this one 1, there are two ways. The first way is that you may want to subtract row 3 from row 1. And that is not what I did. Of course, when you subtract row 3 from row 1, you would have a 1 here. But what I did was very easy. What I did was I took row 1 and divided by 2 to get the new row 1. And as you proceed, I must tell you that it's always easier and good to always show us your row operations. So like this is my row operation. I'm just saying that to get my new row 1, I took the old row 1 divided by 2. And when you do that, divide this row by 2, you would get 1, a half, and negative 1. So let me just ensure that my row operation remains here. Row 1 divided by 2 gives me my new row 1. That's good. Now, so I now have 1 in this position. It's my leading element. I use this leading element to create zeros below it. So to create a 0 in this position, you can see that I need this row 2. I need row 2 minus 3 row 1 And this one will give me the new row 2. And to get the new row 3, I need a 0 in this position. So to get a 0 in this position, I take the current row 3 minus the current row 1. And that gives me the new row 3. So let's do this and see what we get. So I want a 0 in this position. I have already said row 2, which is 3, minus 3 row 1. But row 1 is 1. The element in row 1 is 1. So this gives me 0, and it is 0 you are seeing here. So I come to this other position. I take the element in row 2 is a negative 3, then subtract 3 row 1, and row 1 is a half. The element there is a half. So when I do this, this is the same as negative 3 minus 3 over 2. And this, the LCM there is 2. The LCM is 2. And so this will be negative 3 minus 3. And this is negative 6. Negative 6, negative 3. And so this is what gives me negative 9 over 2. Then I come to this other one. This one. I have negative 1 there, then minus 3, negative 1. That negative one, this one will give me positive. So what I have is negative 1 plus 3, which is 2. Is the 2 you're seeing there. Okay, let's clear this. Now, so we need also a 0 in this position. We say row 3 minus row 1. So 1 minus 1 gives me 0. Negative 2 minus a half gives me minus 2 and a half, which is negative 5 over 2. And then 3 minus 1. That gives me 4. So we are done with that. So what is very important here is that we have a leading element, and we use this leading element to clear the first column. So now we are done with that. We come to the second row, and I can see the leading element is this. We can use this to create a 0 below it. But what I did, I opted to use 1 here. I thought using a 1 here would be easier. And so that is what I used. So I created a 1 in this position. Created a 1 in that position by multiplying row 2. Multiplying row 2 by the negative of this reciprocal. Negative of that reciprocal. So multiply row 2 by negative 2 over 9. Negative 2 over 9. So the whole row 2 multiplied by negative 2 over 9, it will be 1 here, and it will be negative 4 over 9 here. That's what you're seeing. And the other rows remain the way they are. Row 3 remains the way it is, row 1 remains the way it is. So I have a 1 in this position. It's easier dealing with a 1. But I would have left it the way it is, but that would be it would consume much of its time. So now that I have a 1 in this position, I use this 1 to create a 0 below it. How do I create a 0 here? So that means to create a 0 here, I need to take row 3 row 3 plus 5/2 of row 2. That will give me the new row 2, the new row 3. So row 1, I just leave it the way it is. I'm only interested with the elements below this leading one. Those are the only elements I'm interested in to make them zeros. And so, whatever thing I'm doing to this element and this, I'm doing the entire rows. So, -5/2 plus 5/2 of 1 gives me the 0 you're seeing there. I do that again for these other elements. 4 plus 5/2 of -4/9. This gives me 4 minus 20/18. Or let me just say this because this is 2. Minus 10. Minus 10/9. The LCM that would be 9. And this would be 36 minus 10, which gives me 26/9. It is the 26/9 you're seeing here. So what did I do next? What I did next, I decided since that my leading elements have made them to 1. So I make the last leading element also be 1. You can see that this is my leading element. So I make it 1 by multiplying this by 9/26. Multiply by 9/26. And multiply by 9/26 you get to 1. So this is what I have. That's what I have. So next we look at this other example. So let's now look at this example 2 and reduce it to echelon form. And you now know what we're supposed to do. We are using our leading ones to create zeros below them. So in this matrix, looking at this first row, first column position, the leading element there is 1, which we call the leading one. So we use it to create zeros below it. So to create a 0 below at this point, we'll just take row 2 plus row 1. And this will give me the new row 2 that I want. And to get a 0 in this position, I'll take row 3 minus 5 1. So this will give me the new row 3. And so that is what I'll be doing. So let me take row 2, this position plus that. So -1 plus 1 is what gives me 0 in this position. And then -3 plus 2 gives me -1. And then 1 plus -5 gives me -4. And now 5 minus 5 times 1 gives me the 0 here. And -13 minus 5 -3, this will be positive 15. So -13 plus 15 gives me 2. Then here, you take this 13 minus 5 multiplied by 1 is 1. And so we have 8. So let me clear that. Make clear this and that. From the very beginning, I've said that We can use this to be our leading one, but I'm making my work easier by making it positive 1. So to make this one positive 1, I would want row 2 times negative 1. So row 2 times negative 1, this becomes positive 1, this becomes positive 4, and the rest of the rows remain the way they are. I now have created this leading one. I use it to create zeros below it. So to create a 0 in this position, I would want to have row 3 minus 2 row 2, and that gives me the new row 3. So if I multiply this by 2 and subtract from this, I have 0. If I multiply this by 2, this 4 by 2, I have 8. Subtract from this, I have 0. So my matrix is now in echelon form. The matrix is now in echelon form. So I want to take the last example on how to reduce matrices in echelon form. And the example that I'm talking about is this. Just a minute. Let's clear this. So this is the matrix I have. And I want to reduce this matrix to echelon form. Let me just do that. So I have this leading element here. I use it to create the zeros below it. So what I did, I took, to get the new row 2, I took the current row 2 minus 2 row 1. Then to get the new row 3, I need a 0 in this position. So I took the current row 3 minus 3 row 1. Then I need a 0 in this position in row 4. I took just row 4 minus row 1. And then to get a 0 in this position in row 5, I took the current row 5 minus 2 row 1. So these are the row operations I want to carry out to reduce this matrix to echelon form. So let me just take row 2 minus 2 multiplied by row 1. So this minus 2 times 1 gives me 0. 3 minus 2 multiplied by 2 gives me negative 1. 5 minus 2 multiplied by 3 gives me negative 1. And then 1 minus 2 multiplied by this gives me negative 1. Then we have 3 minus 2 multiplied by 2 gives me negative 1. Then finally 3 minus 2 multiplied by 2 gives me negative 1. So I'm done with this row. I now want to carry out this operation. Row 3 minus 3 row 1. So 3 minus 3 times 1 is 0. 7 minus 3 times 2 is 1. 6 minus 3 multiplied by 3 be negative 3. So I did for the entire row and I come up to here. Then let me go to row 4 now. Row 4, I have row 4 minus row 1. So 1 minus 1 is 0. 2 minus 2 will be 0. 3 minus 3 will be 0. 1 minus 1 will be 0. 3 minus 2 will be 1. And then 1 minus 2 will be negative 1. Then I go to row 5. Row 5 minus 2 row 1, because I want a 0 in this position. So 2 minus 2 times 1 gives me 0. 4 minus 2 times 2 gives me 0. 6 minus 2 times 3 gives me 0. So I did for the entire row, and I got -2 in this position and 2 in this other position. Now, so I'm done with this column. I come to this second row where I have this -1 as the leading one. As I've done it from the very beginning, I want my leading element to be +1. So to get +1 here, what I did, I multiplied the entire row by -1. So entire row 2 by -1. That gives me positives, and you can say +1, +1, +1, +1, +1. The other rows, I leave them the way they are. Now I want to use this leading one to create a 0 in this position. The rest I already have zeros, so I have no problem with these two. I only need a 0 in this position. And you can see, for me to achieve this, I need row 3 minus row 2. Row 3 minus row 2. So this, the entire row minus the entire row. So 1 minus 1 gives me 0. -4 minus, no, -3 minus 1 gives me -4. -1 minus 1 gives me -2. And -5 minus 1 gives me -6. -4 minus 1 gives me -5. So I'm done with that. I'm done with that row. Now, you can see that my leading element is now this one. In this row, is now this. So I also make this leading element to be 1. So to make it 1, I divide the entire row by -4. So divide row 3 by -4. So when that happens, this becomes 1, this becomes a half, this becomes 3/2, and this becomes 5/4. And that's what we are seeing. That's what we are seeing here. So let me just now look at what I did. So I have this row now with the leading one here. I need to use this to create zeros below it, but fortunately I already have zeros below it. So the next thing I want is a leading one in this row, a leading element in this row, and we already have it. We already have it as 1. And below it you have elements which are not 0. So we use this one to create a 0 in this position. So for me to do that, I need to take, it is row 5 plus 2 row 4. Now this is row 5, 1, 2, 3, 4. Yeah, row 5 plus 2 row 4. So this -2 plus 2 times 1 gives me 0. And this 2 plus 2 multiplied by -1 gives me 0. So this matrix is in a row echelon form. This matrix here is in row echelon form as we wanted, because we only wanted to reduce it to row echelon form, and that is what we have done.